Hi class, and welcome to another lesson on graphing quadratic word problems. Today what we're going to be doing is we're going to be interpreting these story problems using our graphing calculator. So yesterday you did them by hand, which is a great value. However, we are given these graphing calculators for us to use in this class, and it is a great tool, so let's learn how to use them with our word problems. So for problem number 1, a boat in distress launches a flare straight up with a velocity of 190 feet per second. The height of the flare in feet can be modeled by the equation h of t equals 190t minus 16t squared. So here's what's happening. This boat is having some sort of an emergency. Things aren't going well, so it launches a flare. So as you guys know, if you just kind of think about this flare, they would shoot it up in the air trying to get a signal from a helicopter or an airplane, and it would go something like that. And obviously, what kind of a shape is that? That would be a parabola. And it's modeled by this equation. h of t equals 190t minus 16t squared. So now if you look on letter A says, what is the maximum height of the flare? The maximum height of the flare is going to be this point right there. And that point is called the vertex. So that vertex, which we would find by a negative b over 2a, and then we would substitute to find the y-coordinate. That's how we would find that point. However, this time we're going to use our graphing calculators. So take out your graphing calculators, and let's put this into the y equals. So y equals 190x minus 16x squared. That's what we're going to put in our graphing calculator. Y equals 190x minus 16x squared. Oops. Minus 16x squared. So now at this point, you press graph. And if you kind of look at this one, obviously it doesn't show up on the graph, correct? Let's take a look at our word problem again. It says that the height of the flare can be modeled by h of t means height, and the height of the flare, which would be in feet, right? After t seconds, because this is 90 feet per second, the height is going to be in feet, and the time is going to be in seconds. So if you look at our graph here, class, the height only gives 10 feet. This right here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if that is 10, wouldn't you think a flare would go quite a bit higher than that? I would think a flare would go hundreds of feet up in the air, correct? So we're going to have to change our window a little bit. And a big aspect of this lesson is going to be understanding the problem to set our window accordingly. So what I'm going to think is I'm going to think that my y-axis should go quite a bit up into the air. I might think maybe 300 feet or something like that, just for an example. So what I'm going to do is I'm going to set my window. So the window is on the top, those top 5 buttons. The second one is the window. It's right next to the y equals. And so what we're talking about here is we're talking about our y maximum. Right now my y value just goes up to a positive 10. Let's change that. We can put in anything we want to. Let's just put in 300 for now. We graph it. Okay, now we're seeing something on the graph. We should see a parabola, so I guess we're not going quite high enough. You could put in anything you want as long as it's higher, so let's try another value. Let's try maybe 600. Window. We're going to the y maximum. This time let's try 600. And let's see what shows up. Alright, we're seeing something. We're seeing where the parabola reaches its height, but then when it goes down, we're not seeing when it comes back down and hits the x-axis again. So that means we need to make our x-axis be a little bit bigger. So right now our x-axis just goes right to 10. Maybe let's double it. Let's go right 20. So once again, you're going to go to your window. And you're going to have your x maximum, instead of be a positive 10, let's just try a positive 20. Graph. So as you can see, class, setting up your window is kind of a trial and error experience for you, I guess. If you at first don't succeed and your window doesn't look very good, just reset it to something else. And eventually you're going to come up with a window that gathers all the information. Right now, I'm also going to set my window so that I could see a little bit below the x-axis. It's going to be beneficial for our question part C. So just follow along with me. Set up our window. Instead of our y minimum as being a -10, let's put our y minimum at a -100. So that way we can see it go below the x-axis as well. And now we'll press graph. All right, there's the picture of our flare. And what we want to find, class, letter A, says what is the maximum height of the flare. So what is the y coordinate of that part right there? That's what I want to find. So now listen very closely. Here's how you do that. What you want to do is you want to calculate a maximum value. That top point is a maximum. When parabolas go down like that, they have an absolute maximum point. So what maximum point is that? You're going to calculate that. Calculate is right above the trace button. So if you see those 5 buttons on top, on the far right is the graph button. The button next to that is trace. So second, trace, which is the calculate. And what you're going to calculate here is you're going to calculate a maximum. So you're going to go to number 4. Calculate a maximum, and then you're going to press enter. Now this part's kind of tricky, so pay very close attention. What it asks for here is it asks for left bound. Left bound question mark. So what this means, class, is you have a cursor up top, or wherever your cursor is. You can move it left and right just by pressing, obviously, the left and right buttons. The cursor that I'm talking about is right there. You see, I have a blinking cursor. I can move that anywhere I want to. And my calculator needs to know where this maximum value is. So it asks for, where is the left part of your maximum? You could have it anywhere along the left part. I'm going to choose to have it right about there. Okay? I could probably have it right there. I could have it right here. But the closer you get it to it, probably the better it is. So I'm going to put my left bound at right there. And now I'm going to press enter. Now as you can see, it asks for a right bound region. So I want to go to the right side of my maximum. So I'm going to climb up this hill, and there's the top of the hill, and I want to go to the right side of it. So there is the right bound part of my absolute maximum value. So I ask for right bound. I'm going to press enter right here. Now it says guess question mark. This is where I'm talking about, class. It asks for me to guess. So what I'm going to do is, as close as possible, I'm going to put my cursor right on top of that maximum. So right about there. The closer I get to it, the closer my calculator can approximate. And so I'm going to press enter one more time. And boom, it spits out exactly where my maximum point is. My maximum point is at an x value of 5.937 and at a y value of 564.0625. So let's write that down. Our maximum is 5.937. 5.937, and my y coordinate is going to be 564.06. 564.06. 564.06. There's my XY ordered pair, which, as you can see behind this boat, hopefully that is what you're seeing in your calculator right now. 5.937, 564.06. So in letter A, what is the maximum height of the flare? My x-axis is time. My y-axis is height. And I am looking for what is the maximum height. So I'm looking for the y value. My y value is right here. So the correct answer, how high does that flare go? It goes approximately 564 feet. That is the correct answer for letter A. Approximately 564 feet. Letter B should hopefully be pretty simple now. How many seconds after the flare was shot was it at its maximum height? Well, like I said, the x-axis here is time. Time in seconds. So at 1, 1,000, 2, 1,000, 3, 1,004, 1,005, 1,000, 5.5 approximately. Oh, 5.9, so sorry, so closer to 6 seconds. That's where it reaches that absolute maximum value. So right here is at 5.9 seconds. 5.9 seconds. And now our third one. It says, ignoring the height of the boat, how many seconds will it take for the flare to hit the water? So you know it takes about 6 seconds for it to get to its highest point. And now once it's at its highest point, how many seconds will it take to hit the water? So overall, when it's shot to when it gets to the water again, how many seconds does that take? Well, class, what you want to know is you want to find out what value is this. You want to find when is the height 0. When is your height 0? So when is this right here a 0? Or another way of saying that, class, is on a graph, where is this at? We know that that's where the height is 0, so where is it at on the x-axis? And here's how you find that. What you're going to do is you're going to calculate again. So go to second trace. We have our calculating a value, calculating a 0, calculating a minimum, calculating a maximum. This time we are going to calculate a 0. So go down to number 2. Calculate a 0. Once again, it's going to ask for a left bound and a right bound. This time I want the left bound of the 0 that I'm going to be talking about. And the 0 that I want is right there. So I want to go left of that 0. Left of that 0 is anywhere in here. This is all left of the 0. So I'm going to bring my cursor and I'm going to scroll to the right, but I'm going to make sure I stay left of the 0. So if you want to consider it maybe on top of the 0 in this case, that might be appropriate. So right here I'm left of the 0, so I'm going to press enter. Now it asks for me to go right of my 0. So I'm going to scroll to the right, and now I am on the right side of my 0. You can see how my cursor is kind of hidden here. If I wanted to, I could adjust my window to go down even further. That might not be a bad idea. But I'm going to scroll one more time, and I know for sure now it's to the right of my 0, and I'm going to press enter. And now it says guess. So put your cursor as close as you can onto that 0. Sometimes you can't get right on it in this case, but put it as close as you can. Enter one more time, and as you can see, it tells me my ordered pair. 11.875 and 0. 11.875 and 0. Exactly what, hopefully exactly what this one says. 11.875 is 0. So this point, the height is 0 when the time is 11.875 seconds. So that's going to be your answer for letter C. How many seconds will it take for the flare to hit the water? 11.875 seconds.